Hello everyone, hope you're having a great day and I welcome you all to this day 8 of AWS series. Today's session is about Virtual Cloud Platform or VPC. This session is about networking on AWS. So let's check the agenda for this session. In this session you will learn about what is VPC service on AWS, what are subnets, types of subnets and how to create a VPC on AWS. That's all for the agenda. So without any further ado, let's begin. Before we begin, subscribe to Intellipaat and don't forget to press the bell icon to get more updates.
Today in this session, we will be going through some of the topics that you should know when you're trying to learn Amazon VPC, right? What is Amazon VPC? So guys, Amazon VPC is basically a service. It's basically a virtual private cloud, which is given to us by AWS when we deploy resources on its cloud platform. And what this Amazon VPC basically enables us to do is basically launch AWS resources into a virtual network that we define, right? So VPC is basically a virtual network that we define. This virtual network can have multiple subparts as well. It can have multiple configurable properties as well. And the whole service is called Amazon VPC, right? Now, the definition is not that important, but the working is the most important for Amazon VPC, through which you will be actually able to understand what you can accomplish and what all is possible when you are basically making use of the Amazon VPC service. So let's go ahead and understand how Amazon VPC service basically work. So guys, this is the skeleton diagram for Amazon VPC, and you can imagine how you can basically how internet basically works at your home system or in your office system by looking at this diagram. So what basically happens is, first there is the internet, right? So you are first always on the internet, and from the internet there is a request which comes in. So let's say you are at your home system, and if somebody has to reach out to your computer, let's imagine it like that. How will it work? So first you have the internet, and from the internet there will be a request which will come in. Now in AWS, what happens is, like I said, you have a virtual network that you create. So first of all, any resource in AWS that you create is enclosed inside a virtual network. It could be EC2, it could be any databases. So it has to be enclosed inside a network, right? So we will have this network. Let's say this is the network of ours, which is called the AWS VPC service. And any network or any internet connection which has to come inside this VPC service will have to come in through something called as a internet gateway. Okay, so when you create a virtual network, for that virtual network to have internet access, you basically need to create a resource called internet gateway, and this internet gateway is going to be a single point through which internet requests are going to go out, and internet requests are also going to come in, right? So the internet can basically be accessed using the internet gateway, and whenever a request is coming in through the internet, the first place that it goes to after the internet gateway is to a resource which is called routing table. Now what is a routing table? Now when you create an AWS network, what happens is you also have something called as the subparts of the network or sub networks, let's say, right? So let's say you create an AWS network, and in that AWS network you create two subparts which are basically called subnet 1 and then subnet 2. So these two subnets will have their own resources inside it. So let's say in subnet 1 you have a database which you have deployed, and in subnet 2 you have a EC2 machine or a virtual machine that you have deployed. Okay, now let's say if the internet has to reach to this machine which is there in subnet 2, the way it is going to work is, first the request is going to come in from the internet gateway. From the internet gateway, now the request does not know how to reach the machine. So what it will refer to is basically something called as a routing table. So in the routing table, basically you will have all the details with respect to which how can you reach the resource. So this resource will basically have a private IP address, right? And this private IP address can be reached out to using the routing table. right? Or in other words, you can also imagine it something like this, that how will the internet gateway know about these resources? The internet gateway knows about these resources when it is basically a part of the routing table. So when the routing table is visible to the internet gateway, then these resources are also visible, right? And from the routing table, basically you reach the subnet 2, and in subnet 2 you have that resource. Okay, so this is a skeleton of what AWS VPC is. First, the request comes in through the internet gateway. The internet gateway refers to the routing table, and from the routing table you basically go through the subnet where you have the resource, and from the subnet you go to the resource. Okay, now there are something called as firewalls in this architecture. Now you will ask, okay, you just told us that the request just comes in, so how is it filtered? So that filtering process happens using firewalls, and there are two kind of firewalls in VPC. The first firewall is called NACLs, right? And this network access control lists, these are called, and these basically operate at the subnet level. That means that there is a firewall at a subnet level, and there's a firewall or the instance level, which is basically, or the resource level, which is basically called security group. So there are two levels of firewalls in a VPC network. Okay, so that basically means that when the request is coming in, there is no filter which happens on the AWS VPC level. The only filter which happens is on the subnet level, which is the network ACL. Okay, from the network ACL, if the request gets filtered, then it basically goes to the security group of the resource. So if I were to include these two firewalls in the diagram, it can be imagined something like this. That first the request will come from the internet. From the internet gateway, it will look for the instance that it has to go to in the routing table. From the routing table, once it gets to know where the resource is, it will go there. And in the subnet, it first has to basically go through the first level of firewall, which is the network ACL. From that firewall, it then goes in if the request is filtered out. And when that request is filtered out, then it encounters another firewall, which is basically called a security group. And if it filters that out, then only it is able to access the resource. Okay, so this is the flow diagram of how a request flows in a VPC. And now what I'm going to show you guys is basically how to create this kind of an architecture in AWS, right? So what we're going to do is I'm going to quickly jump on to my browser and let me open AWS Management Console. Give me one moment. All right, guys. So first you have to basically go to aws.amazon.com, and on aws.amazon.com, you basically will sign in. And this is where you will reach your AWS Management Console. Now on the AWS Management Console, what we have to basically work with is virtual private cloud. And let's try to now create the architecture. So this is how our architecture looks like. So first what we'll do is we'll create AWS VPC, right? So let's go ahead and create a VPC. So we'll click on VPCs, we'll click on create VPC, and whatever I've explained to you guys, we will try and test it out by doing the hands-on. So that is what we are going to do. Okay, so first let's name our VPC something. So let's call it VPC demo 1. Let's call it that. And now let's give it a IP address range. This IP address range will basically mean that all the resources in this VPC are basically going to have an IP from this particular range, which we are now going to define. So let's go ahead and define a range. Let's say it's 192.1.0.0/16, right? Let's say this is the range. And now we'll basically go ahead and click on create VPC. So our VPC has now been created, and what we have done is we basically went ahead and created a simple network. We have not defined any of these resources as of yet, right? We have just created an empty box, which is our AWS VPC. Now, whenever you create a VPC, guys, what happens is automatically, when you will go ahead and create subnets, it will automatically create some resources, and I will tell you that. So right now, these subnets are of some other VPC that they are not of the VPC that I created, right? So what I'll do is I'll go ahead, and create two subnets, which is subnet 1 and subnet 2. So let's go ahead and create that. So let's click on create subnet. Let's call it subnet 1 hyphen demo. And the VPC obviously is going to be VPC demo 1. This is the one that I created. Now, this subnet can be deployed in 3 availability zones. These are basically different data centers that AWS has in the region that we are working in. Let's deploy it in the first data center, 1A, right? And now we have to specify an IP range, which is basically going to be a part of the main range, which is there of the VPC, right? So let's specify a range 192.1.1.0/24. So this is going to be the range of the subnet that we are basically creating right now. So we'll click on create. And now the VPC1 subnet 1 has been created. Similarly, we'll create one more subnet. Let's say it's VPC1 subnet 2. Right? The VPC is going to be VPC demo 1. This time, let's say the data center is going to be of 1B. Right, and specify the IP range as well. So this is going to be the IP range. Okay, let's click on create. Okay, so my second subnet has also been created. So if we refer to our diagram again, so we basically created a VPC, we created 2 subnets, and now let's create the routing table. Okay, now right now I have not created any routing table, but if you go to your routing tables, you will be able to see that this is your VPC's routing table. As you can see, it's VPC-demo 1, and this is automatically created. Okay, so this is whenever you create subnets, a routing table is automatically created, and this routing table, if you want to look, what subnets it is basically associated to. So you can just click on subnet associations. It is not, basically created by, or it is not basically connected to any subnet as of now, right? So a routing table is automatically created. And why is it created? Let me show you that as well. So if you go to routes in this, you will basically see that there is already a route which has been added, which basically says that all the IP address from this range can basically talk to each other in this virtual network. So this is the default rule, which basically says that if I deploy this resource and if I deploy this resource, they can talk to each other. Why? Because that is the default rule which is present in the routing table. Okay, so these two will be able to talk to each other. Why? Because this rule is present, and this rule is by default, and this rule you cannot delete as well. Okay, so this is one thing. Now what we want to do is, since these two subnets can talk to each other, but they cannot talk to the internet as of now. So that is something that we are going to configure. But how does the routing table know that which subnets can talk to each other? Okay, so for defining that, what you'll have to do is you'll have to click on subnet associations, click on edit subnet association, and include these two subnets over here. So when you do that, now this routing table says that both these resources can talk to each other via the routing table. And now what we want to do is we basically want internet to be available in this routing table as well, right? So we are going to configure that. But right now, let's not configure the internet. And let's see what will be the behavior in case we don't add the internet. Right, what we are basically going to do is let's go ahead and define the firewalls now. So let's first define the network ACL. So again, in this case, if you go to NACL, this is basically the subnet level firewall. So over here you can see there's already a network ACL which is created for VPC demo 1, right? So this is also created by default. And if you look at the inbound rules or the outbound rules, so what is this firewall saying? That all traffic is right now allowed. So anyone who wants to have access inside this subnet, inside both the subnets, because both the subnets are associated to this NACL or this firewall right now, all traffic is enabled to all the subnets in this particular network. Okay. Similarly, if you look at the outbound rules, you can basically request anyone on the internet from within these two subnets. So that is what our network ACL is right now saying. Okay, so we're not going to touch that. So let's move on to security groups now. And when we move to the security groups, over here as well, you will be able to see that there will be a default security group which will be created, and which VPC is ours, we can basically make out by looking at the IDs, right? So our VPC is of the ID 69D, right? So that's what we have to look out in the security groups. So we'll go to security group 69D, right? This is the VPC ID of us, and this is the security group that is basically created by default. So let's name this as default security group or default demo 1. Let's name it that. So this is our security group which has been created, and if you look at this security group's inbound and outbound rules, they are going to be very limited, right? So all traffic is allowed, but it is only allowed from within the resources which are connected to this.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Amazon S3 is which type of storage service? A. Object. B. Simple. C. Secure. D. Block. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Security group, right? So we can change this if we want. So we want anyone to be able to go through this firewall. So I'll just specify anywhere and we'll click on save rules. Okay. So now what we have done is we have opened both our firewalls, that is the subnet level firewall and the instance level firewall, right? One last thing that we should do before we can go ahead and deploy these resources inside these subnets is basically to tell these subnets that these resources can have public IP addresses. Okay. So how do we go ahead and configure that? So just select your subnet. So let's say this is subnet 1 demo 1 that I have basically went ahead and selected. So what I'll do is I'll click on actions, click on modify auto assign IP settings, and here I will say auto assign IPv4 address. So this by this, now what is going to happen, that any resource that I'm going to create inside this subnet, it is automatically going to have an IP address. Similarly, I'll do that for my subnet 2 as well. So let me specify the name correctly. This is subnet 2 hyphen demo 1. And in this, again, I will say that basically any resource which is deployed in this should have a IP address, a public IP address. Okay, all set. So now what we have done is we have not configured the internet gateway yet, but we have created a network. Inside this network, we have a routing table, and this routing table has a default rule, which basically is allowing both these subnets to talk to each other. We have created this firewall, which is allowing all traffic. We have created this firewall as well, which is allowing all traffic. Okay, so let's go ahead and test this architecture out. So what I'll do is I'll go to EC2, and now I'll go ahead. I'll basically go ahead and launch two machines, one in subnet 1 and the other in subnet 2. Okay, and there is a behavior that I want you guys to notice. So first I'll go ahead and create an Ubuntu machine. I'll create a t2.micro, which is basically going to be a part of VPC-demo1, right? It is basically going to be in, let's say, subnet 1. And other than that, everything can be left at default. In the security group, we are basically going to configure or select the default security group that we created, right? And now let's go ahead and click on review and launch. So now what we'll do is we'll basically select a key that we already have. So I'll select Mac-Mumbai. I already have this key and I click on launch instances. So with this, I have launched a machine in subnet 1. Now I want you to notice something. This is subnet 1 machine. And this is being deployed. While this is being deployed, let's deploy the second machine as well, which is again going to be an Ubuntu machine, t2.micro. It is going to be a part of our demo 1 VPC. It's going to be in subnet 2, going to be a part of the default security group. Let's review and launch. It's also going to have a key pair, which I already have. And now this machine is also launched, and this is going to be a part of subnet 2. Now, what is something that I want you to notice? So first of all, this will have an IP address because we specified in the subnet that the machine should have an IP address. But now if I try to connect to these machines, you will see that I will not be able to connect to them. So if I open my terminal really quickly, and let me try to go ahead and connect to these machines, you will see I will not be able to connect to them. It will basically give me a connection timed out kind of a request. And the reason for that is because I am on the internet, I'm trying to connect to these resources, but this internet gateway is not there, right? This internet gateway is the only way that this VPC will be able to talk to the outside world, okay? And because it is not there, you will see I'm getting a connection timed out kind of a thing. So how can we fix this? So now let's go back to our VPC console and let's go ahead and create something which we call as an internet gateway, right? So we'll go to VPC. Inside VPC, we will go ahead and go to internet gateways. And in this internet gateway, I'm going to create this. This is a default internet gateway which is attached to the default VPC that we created. And what we're going to do is we're going to create one more internet gateway. Let's call it IGW demo 1, right? And let's create it. Once it has been created, what we'll do is we will attach it to our VPC. So right now it's in the detached state. So I'll have to do and click on actions, click on attach to VPC and attach it to VPC-demo 1. Attach it. So it's attached. So now that it's attached, guys, we should be able to see this internet gateway in our route tables, right? So if I go to my route table, so this is my route table. This is the demo 1 route table, right? So if you go to routes, we can click on edit routes, and now we can add a route for the internet gateway, which is IGW-demo 1. We'll add that, and the whole internet can be accessed using this internet gateway. We'll click on save routes, and now if we go ahead and try to run the same command, you can see I'm able to connect to my machine. Isn't that great, right? So now, since we are able to connect to this machine, we should be able to connect to the other machine as well. So let me connect. And let's go to our second machine's IP address. So this is a subnet 2 machine. Let's connect to it. This is the IP address. All right. So now, as you can see, I have successfully connected to these two machines. And now let's see if these two machines are able to talk to each other, right? So how can we check if they're able to talk to each other? So if we try the public IP address, obviously they will be able to talk to each other because this is going to be via the internet. But what we want to see is whether they can talk within the network. And for that, we are basically going to make use of the private IP address. Okay. So this is the private IP address of subnet 2. So what we are going to do is from the subnet 1 machine, I try to ping subnet 2. And as you can see, I'm able to ping the machine in subnet 2. Why? Because in the route table, we have that entry wherein they are able to talk to each other. Great. So now let's try something out. So what we can do is we can go to, since subnet 1 is able to talk to subnet 2, let's go ahead and go to network ACL. That is basically the subnet level firewall. And there, let's try something out. So we'll go to.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
VPC. And in VPC, we will now go to network ACLs. So let's create a new network ACL. It will basically be subnet 2 hyphen demo 1. And this is going to be a part of VPC demo 1 VPC. Right. And let's say this is for subnet 1 and this is for subnet 2. So in this, what we can do is we can remove the subnet. Let's remove the second subnet. Let's say in this subnet, I go ahead and I specify that only network connection from subnet 2 is possible from subnet 1, but subnet 1 from subnet 2 is not possible. That means that let's say only this machine can ping to machine 1 and machine 1 is able to ping to machine 2. Now, how is that possible? I will just specify that all traffic from machine 2 is allowed, but from machine 1 is not allowed. So we'll specify something like this. So 1 second. Okay, so I basically just have to add /20 over here, save it. Okay, so now what I've specified is that only subnet 2 is able to ping into the network ACL. Now, what does that mean? That basically means that if somebody is trying to go ahead and ping subnet 1 to subnet 2, it should not be able to do it. Let's try it out. And now you can see since I have edited the network ACL, I am not able to use these machines from my personal system as well. And the reason for that is now the subnet is not allowing my machine as well to connect to these machines. Okay, so let me make you understand that using the diagram over here. So what we did is basically these firewalls, these subnet level firewalls, have only allowed connection from machine in subnet 2. Only this IP address I have added in this firewall. Now, because of that, what is happening is from the internet, I'm not able to reach this subnet. Why? Because this firewall is blocking me. So I'll not be able to SSH into this machine now. Okay, so let's try to change what we were doing. Let's again go back to network ACL. So I'll go to VPC and we'll again click on edit inbound rules. We can again make it 0.0.0.0/0. Save it. And now again, if I come back to my terminal, I should be able to connect, right? Similarly, I should be able to connect over here as well. Okay, so instead of, let's say, changing the subnet level firewall, let's go ahead and change the security group firewall, right? So in the security group firewall, what we can do is we can tell that only my machine should be able to ping it, right? And then only subnet 2 should be able to ping inside it. Subnet 2 machine should be able to ping inside it. So how can we do that? Let's go to security groups. So our security group is this one, 69D. So let's go inside it, click on edit inbound rules. And all traffic is allowed only from my IP. This is my machine's IP. And only from, let's say, I want to go ahead and allow only subnet 2 to be able to ping inside it. Subnet 2 machine to be able to ping inside it. Okay, let's click on save rules and let's see how this is going to work now. So now in this case, my SSH is going to work perfectly fine, right? So if I will try anything over here, it will work perfectly fine. If from my first machine, I try to ping machine 2, let's see what happens. So according to the rules that I have configured as of now, if I try to ping subnet 1 to subnet 2, according to the rules that I've configured, it should not connect, right? But let's see if our assumption is correct or not, and then I'll explain whatever the behavior is happening over here. Can you see we are not able to ping the first machine, that is subnet 1 machine to subnet 2 machine? Okay, this is the subnets 2 private IP. This is not able to ping, or on the diagram, this machine is not able to ping this machine, right? And why is that so? Because in the firewall for these machines, what I've configured is that only this machine, the subnet 2 machine, can go ahead and ping the other machine, or only this machine's IP address is allowed in the firewall and no other machine can ping, which basically means if I go ahead and go to my second instance, and if I try to ping the first machine, I should not have any problems. So if I select subnet 1 machine over here, select the IP address from here, come back, set the IP here, hit enter, you can see the ping is working, right? And why is that so? Because in these security groups, I have specified that only my subnet 2 machine connections will be allowed. So if I go ahead and change this, if I go ahead and make this 192.1.0.0/16, if I make that to basically work, now what will happen? So let me just verify if this is a CIDR range. Yes. So this is a CIDR range for all the instances or all the resources in this VPC. If I click on save rules now, you can see that this ping now again started to work, right? Why? Because this particular rule is now allowing everyone inside the VPC to be able to ping each other, right? And hence this ping started to work. Again, if I go ahead and if I change it to, let's say, only subnet one machine being able to ping each other, then it will be a different story. Just give me one moment. Okay. All right. Okay, guys. So now if I go ahead and change this to only subnet one machine's IP address, what is going to happen then? In that case, only subnet one machine will be able to ping subnet 2 and the other way will not be possible. So if we save the rules, so now you can see both of these are working, right? So let me clear the screen once more and let me start this command. Right? So now if I go ahead and save the rules, you will see that this is going to stop now in a few moments. So what we have now added, that we have added that only subnet 1 will be able to talk. So if we try this out. So subnet 1 connections are allowed and subnet 2 connections are not allowed. So if I try to ping from subnet 2 to subnet 1, this should not be allowed now. Can you see? The ping has now stopped. And why is that stopped? Because we have changed the firewall rules so that only one machine should be able to talk to each other. All right. Great. So guys, I hope this particular diagram is clear. So what we have done so far is we have created a VPC, we created two subnets. These two subnets, we basically had a routing table associated with it, which is created by default. This routing table did not have access to internet. So we created an internet gateway and we included that internet gateway in the routing table. And then we were able to basically access both the subnets from the internet. All right. Then we went ahead and configured the two types of firewalls that we learned. First is the network, the subnet level firewall, and then we try to configure the instance level firewall. Right. Now let's go ahead and understand the different kind of subnets right now. So the only thing that we understood is that we could create two subnets, but there can be two types of subnets which you can basically go ahead and create. The first subnet is basically called a public subnet, and the other subnet is basically called a private subnet. So a public subnet is a subnet which can basically be accessed by the internet, and a private subnet is a subnet which cannot be accessed by the internet. Now, what do we mean by that? So right now, both our subnets are being able to be accessed by the internet. But what I want is only one subnet should be able to be accessed by the internet, and the other subnet should not be able to access by the internet. Now, how is that possible? How is that possible? So it is possible using an architecture like this. So what we are basically going to do is we are basically going to have two subnets. We are going to have an internet gateway, but from the main routing table, we are going to not associate that routing table to our subnet 1, right? We are going to create a separate routing table for our subnet 2, right? Which is not going to be associated with the internet gateway. So all in all short, in the first routing table, the main routing table, we are going to remove the subnet 2 and we'll only have subnet 1, which is basically going to access internet. And we are going to create one more routing table so that our second subnet can associate with it and then be able to talk to the first instance or the subnet 1 instance. Okay, so let's go ahead and implement an architecture like this. So what we need to do in our existing VPC is, here nothing will change. Subnet level, nothing will change. In the routing tables, what we're going to do is, this is my demo 1 routing table. Let's say this is going to be my public routing table, since this already has the internet gateway attached, right? Let's create one more routing table. Let's call it as demo 1 routing table, but this is private. Okay, and this will be associated to VPC demo 1 VPC. Let's create it. Okay, this is created. Now in the demo 1 public routing table, we are basically going to go ahead and edit subnet associations. And I want to remove subnet 2 from over here, which is this. Let's remove this. So only subnet 1 I want to associate. So I'll just click on save. So now only one subnet is associated, which is subnet 1, which basically means if I try to access my instances, now let's try to SSH. This is subnet 1. Let's try to SSH into it. This is working perfectly fine. Okay, this should not work. Let me check what has happened. So this is the routes. This is basically having an internet gateway for this subnet, which is fine. Then we have this routing table. Okay, so in this I will have to edit. I will have to select the subnet, save it. Okay. And now you can see that this instance has stopped working. I can just quickly go ahead and try connect to the subnet 2 machine, which is this IP. You can see I'm not able to connect now, right? And why am I not able to connect? Because for my second subnet, it is now not having any route for the internet gateway, right? But for my first machine, it is having a route for the internet gateway. So that's why if I exit this and try to connect again to my first machine, the subnet 1 machine, I'm able to connect, but for this machine, it is giving me an error now, or it is not connecting. Why? Because this machine no longer has internet access. Okay, but what we can do is we can try connecting to this machine, the subnet 2 machine, from within the VPC, which basically means that if I come back to my diagram, okay, so in this, now what is basically happening is that from the internet, from the public route table, I'm able to connect to subnet 1 machine, but from the internet, I'm not able to connect to subnet 2 machine. So what I can do is, and observe, the reaction over here, that I will be able to go inside this VPC and I will be able to connect to subnet 1. From subnet 1, I will be able to connect to this machine, right? Now from this machine, I can basically go through this route table and then connect to this machine. Do you understand this network architecture, right? So from this route table, obviously I cannot connect to this subnet because this route table does not have any details regarding this particular subnet. Okay, but this particular route table, the private route table, has basically allowed connections between these two subnets, and because of that, what we can do is we can basically go ahead and connect to this machine, and from this machine I can SSH into this particular machine, but it obviously has to be using the private IP addresses. Okay, so let's try that. Let's try that over here. So what I'm going to do is, first I need on my subnet 1 the key pair. So let me go ahead and copy the key pair. So I'll just go ahead and copy the key pair on this machine. Done. Let me again go inside it. So I'm inside the first machine now, and I have this key pair over here. Let me give it the required permission. It has it. And now let's try to go inside the second machine. And that we will do now using the private IP.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Amazon S3 has how many pricing components? A. Only 4. B. Only 5. C. Only 3. D. Only 2. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And as you can see, I'm inside the second machine now. So you can see the IP address is 192.1.2.96. This IP address is 192.1.2.96. However, if I try to go through the public IP address from my machine into it, I will not be able to do that since there is no internet connection. But because there is a possibility, or there is a connection between this machine and this machine, I'm able to SSH from this machine into the subnet 2 machine. Okay, and that is what we have just done. Great. So now we saw how to create a machine with no internet access, and I can show you guys that there is no internet access. So since this is subnet 2 machine, if I try to curl google.com, you can see there is no response, right? It basically just hung. Why? Because google.com is not reachable. However, if I go back to my subnet 1 machine, so I have just exited the SSH of the second machine, and I'm now inside the first machine. As you can see, the IP address has changed. So if I go over here and try to do curl google.com, you can see that I'm able to see some content from the internet. But in this case, I was not able to see any content. Why? Because the second machine does not have internet access, and the first machine has internet access. Now, in what cases will it be beneficial? It will be really beneficial in cases wherein the let's say in subnet 2, I have a resource which I do not want anyone from the internet to be able to access. Okay, why I don't want that? Because probably it's a very critical machine for me. I don't want this machine to be hacked in any sort of way, right? So that's why I do not want anyone from the internet to be able to reach it out. So in that cases, what we do is we create private subnets, right? Now there is a use case wherein probably somebody from the internet should not be able to reach out to this subnet, but from within the machine, if the machine wants to access internet, that should be possible. So how can that be achieved, right? So that can be achieved, giving internet access to private subnets, that can be achieved using something called as NAT gateways. So what are NAT gateways? NAT gateways are basically resources which help private subnets to use the internet. Now, how does it help it? By basically giving a proxy connection to the internet gateway. So what's going to happen is it's basically going to help us connect to uh, the private or the public subnet, and from the public subnet we will be able to access the internet. So basically, you can imagine it like this, that a NAT gateway is going to be a machine which will be deployed in the public subnet, and our system is going to ping that machine to access the internet, right? So that is what a NAT gateway is.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job.
Now that we are done with the session, don't forget to subscribe to Intellipaat and press the bell icon to get the latest updates on Intellipaat.